Hi everybody, in this video I'm going to go through our lesson on directed line segments, and the first thing we need to kind of revisit is the definition of a midpoint. So a midpoint is a point that divides a segment into two congruent parts. A lot of times this is thought as averaging. It's the average of your x and y coordinates. So you find your x coordinates, average those together, find your y coordinates, average those together of your two endpoints. So if we're working with, an x1, y1, and an x2, y2 as our two endpoints, the midpoint can be found by the midpoint formula. So we introduced the midpoint formula in Algebra 1. And again, it's really just the average of your x and y coordinates. So this midpoint M, it's a point itself. So it is going to be an x comma y. And your x coordinate itself is found by adding your two x values. So we'll start with the second one here, x2 plus x1 divided by 2. And then your y coordinate will be found by averaging your y coordinates. So y2 plus y1 divided by 2. You also could do x1 plus x2 divided by 2. I did it this way. Okay, so what is a directed line segment then? Directed line segment. And it really is a line segment where we are taking into consideration the direction. So segment between two points. So for example, maybe they are points A and B with a specified direction. And I'm going to say initial point and direction. So a specified initial point where the segment begins and the direction it's going in. So there is a difference between segment AB and segment BA. AB means the segment from point A to point B, and BA means we are starting at point B and we are going towards point A. A lot of times that doesn't matter, but now that we are working with these directed line segments, it does. So why do we really care about these? Well, they can be partitioned. We can find the midpoint of a segment, or they can be partitioned into smaller segments based on a given ratio. Given ratio. So let's kind of draw a giant AB here. So this be my segment A, B. And I am going to kind of divide this up into 1, 2, 3, 4 parts, right? So I have the first piece, the second piece, the third piece, and the fourth. And let's say I'm going to look at this point here, P. So point P partitions segment AB into a ratio of 1 part, right? Because I have 1 part here to 3 on the other side. So point P partitions segment AB into a ratio of 1 to 3. So I have 1 part plus 3 parts on the other side for a total of 4 parts altogether. So that's kind of a secret piece that is unlocked. You can break it up into a certain number of parts, and then the total is if you add up your total number of parts. So if you have a total number of parts that is a power of 2, you can use the midpoint formula. So if it is a power of 2, that means the total number of parts that we have is 2 parts, or 2 squared, which is 4 parts, or 2 cubed, which is 8 parts, or, so on and so forth. Then we can use the midpoint formula. Or, which color do I want to use? I guess orange. If the total number of parts is not a power of 2, and really, in all cases, this works. We can use the section formula. So the OMHS says if you do not have a power of 2, then use a section formula. It actually works in every case, even if you have a power of 2, just sometimes, the midpoint formula might be a little bit quicker. So what is the section formula? So the section formula says 4 endpoints, x1, y1, and x2, y2 of this directed segment the coordinates of this point for endpoints, the coordinates of the point that partitions the segment into a ratio of m to n. Oops, I didn't write of. R. So again, we are finding these coordinates of a point that partitions the segment into a ratio of m to n. So those coordinates are m times x2 plus n times x1 divided by m plus n. That will give you your x coordinate. And your y coordinate will be found by multiplying m times y2 plus n times y1 divided by m plus n. And it is super important that you multiply the first number in your ratio, which is m, times x2 and y2. And then you multiply the second number in your ratio n times x1 and y1. If you flip-flop that, your answer will not always be correct. I've learned that the hard way. All right, so let's look at some examples. So number one, the coordinates of the midpoint of segment MN are 1, 0. What are the coordinates? Oh, whoa, I skipped part of that. It's supposed to be after the period if m is -2, 3, what are the coordinates of n? All right, so this is just telling us that we have some segment here. If it helps to draw a picture, please do so. Here's m, here's n, and we have this midpoint, right? This is the point 1, 0, and we know m is the point -2, 3, and we want to know what is this point, right? So let's think back to our midpoint formula. So the midpoint formula will give us an x, y, or if I add x2 plus x1 and I divide that by 2, that will give me the x coordinate. And if I add y2 plus y1 and divide that by 2, that will give me the y coordinate. So let's kind of think about this. I know the midpoint, right? Our midpoint is 1, 0. And this is going to be equal to, well, I know one of the points, right? I know one of the x1s and y1s. We know m, which is -2, 3. So let's let x1 be -2 and y1 be 3. So this midpoint, 1, 0, it'll be found, and I'm going to actually make this a little bit bigger, by first adding x2, which we don't know, right? That's going to be n. N will be whatever x2, y2 are. So I have x2 plus our x1, which our x1 is -2. That will be divided by 2 to give us our x coordinate, which we already know is 1. And then the y coordinate, we don't know what y2 is. Whatever it is, it was added to y1, oops, which is y1 is 3, and then divided by 2. All right, so I have a set of x values, right? I know that 1 was found by taking x2 plus -2 and dividing it by 2. So 1 equals x2 plus -2 divided by 2. And I know that the y coordinate 0 was found by taking y2 plus 3 and dividing it by 2. So I'm going to write that over here. Our y coordinate of 0 was found by taking y2 plus 3, dividing it by 2. So now I really have two different equations that I can solve for x2 and y2. So looking at the kind of like darker green equation up here, to get x2 all by itself, the first thing I'm going to undo is the division by multiplying both sides of the equation by 2. So that the 2 in the denominator and the numerator cancel. So I have 2 is equal to whatever x2 is plus -2. And then I can simply add 2 to both sides to get rid of that minus or that -2 that's there. So that way I now know that 4 is our value of x2. So that's our x2 coordinate. And then now let's look at the y2. So I can kind of follow the same sort of first step, undo the division by 2 by multiplying both sides by 2. Oops. So that way it will cancel, leaving us with just y2 plus 3 on the right is equal to still just 0. And now I can get y2 by itself by subtracting 3 from both sides. And this will tell me then that y2 is -3. So now I have the coordinates of n, right? N is this second point, this x2 comma y2. So this means n really is x2, the x2 we found was 4, and the y2 we found is -3. All right. Let's do number 2. The coordinates. Oh, no, the endpoints. I was looking at the above one. The endpoints of directed line segment WV are V is the point -10, comma 6, and W is the point -2, comma 18. What are the coordinates of the point that partitions WV into a 1:3 ratio? All right, so kind of a little bit to dissect here. First of all, we have this segment WV, and that's kind of important here that it starts at W and goes to V. And then they tell us that V is -10, comma 6, and W is -2, comma 18. Now we want to break this into a 1:3 ratio, which means I want to have in total 1 plus 3 or 4 parts. So I want to split this up into 4 parts, and there are really a couple different ways you could do this. I could find the midpoint twice. So I could find the midpoint of this segment, and then I could find the midpoint. Let's see, let's call this point M for midpoint. I could find the midpoint between M and V. And this would be the coordinates that we're looking for. Oh, wrong way. I went the wrong way because from W to V, we should have 1 part closer to W and 3 on the other side. So we would actually want to find the midpoint between W and M. It's good to make mistakes. W and M, we had this midpoint in here, and whatever this point is, we'll call this point P, this would separate WV into a ratio of 1 part to 3 parts. There would be 3 total parts on this other side. So you could find the midpoint twice, or you can use the section formula. You can always use the section formula, which is what I'm going to do here. So our section formula, it's going to be a point, and you will multiply m times x2 plus n times x1, and you will divide that by m plus n, and that will give you your x. And then the y coordinate will be found by multiplying m times y2 plus n times y1 divided by m plus n. All right, What I like to do for this first is I kind of like to rewrite this and use my M and N. So what are M and N? Well, we have this ratio 1 to 3. So this is like M is 1 to N is 3. So I'm going to rewrite this. They both are fractions with plus signs in the numerator and the denominator. And now our M is 1. So I have 1 times whatever x2 is, plus 3 times whatever our x1 is. And then that'll be divided by M is 1 plus N is 3. And then our y coordinate will be found by multiplying 1, which is M, times y2, plus 3, which is our N, times y1, and dividing that by M plus N, or 1 plus 3. And now I can substitute in the x2, the x1, all that jazz. So it might be helpful even to label those. So W is our first point, so that will be x1, y1, and then V is our second point, our x2, y2. So I have 1 times our x1, x2, and our x2 is negative 10, so I have 1 times negative 10 plus 3 times our x1, which is negative 2. And all of that will be divided by 1 plus 3, which is 4. And now I'll do the same thing for our y coordinate. I'll just substitute in the y2 and the y1. So I have 1 times our y2, which is 6, plus 3 times our y1, which is 18. And all of that will be divided by 1 plus 3, which is 4. All right, using the order of operations here, oops, I meant to do the parentheses first. We have 1 times negative 10, which is negative 10, plus 3 times negative 2 is negative 6, divided by 4. That'll give us our x coordinate, and then our y coordinate is found by 1 times 6 is 6, plus 3 times 18 will give us 54, divided by 4. And we can add and then divide. So negative 10 plus negative 6 is negative 16 divided by 4. And 6 plus 54 is 60 divided by 4. And then simply dividing negative 16 by 4 gives us negative 4. And 60 divided by 4 is 15. So that was using the section formula. Let's look at one more example with the section formula. Number 3. Oops. What are the coordinates of the point on the directed line segment from negative 8, 6 to negative 3, negative 4 that partitions the segment into a ratio of 2 to 3. All right, so this doesn't even really give a name to the segment. We just have these 2 points. So if I wanted to, I could call them A and B. And A is the point negative 8, 6, and B is the point negative 3, negative 4. And we have this ratio, right? 2 to 3. So that means M here is 2 and n is 3. If you want to write that out even, you can. M is 2 and n is 3. And then our first point, -8, 6. -8 will be my x1, 6 will be my y1. And then in the second point, -3, -4, -3 will be my x2, and -4 will be my y2. And this point, right, this partitioning point is going to be found by the formula. It's a point itself, m times x2 plus n times x1 divided by m plus n. And then m times y2 plus n times y1 divided by m plus n. And that will give us this point. Now, first of all, let's kind of give a little bit of a visual here. If we're breaking this up into a ratio of 2 to 3, that means all together, let's see right over here, we have 2 plus 3 or 5 parts. Maybe that looks something kind of like this. That's not very good, but maybe it looks something like this. And we are looking for this point where A to that point P is 2 parts and P to point B is 3 parts. That's what we're looking for. And here is how we find point P. Okay, I always like to rewrite this formula and just substitute in the m and the n values first. So m is 2, so I have 2 times x1 plus our n is 3. Oh, I always do this. I want to put x1 first, and in the section formula, that's not the case. You multiply m times the second value, so it'd be 2 times x2 plus n is 3 times x1 divided by m plus n. And then I will multiply m is 2 times y2 plus 3 times y1 divided by, and I should actually add m plus n, or 2 plus 3. All right, so let's substitute in all of our values. This is going to give us this point, and we have 2 times our x2, and our x2 is -3, so I have 2 times -3 plus 3 times our x1, which is -8, divided by 2 plus 3 is 5. And then our y coordinate is going to be found in kind of a similar way. I will have 2 times our y2, which is -4, plus 3 times our y1, which is 6. And that will be also divided by 5. And now I can simplify this a little bit more. 2 times -3 is -6, plus 3 times -8 is -24. So this is like -6 minus 24 over 5. That'll give us our x coordinate of this partition. And then 2 times -4 is -8, plus 3 times 6 is 18, divided by 5. And some of these, they might not always be a whole number. It might be, you know, a fraction or a decimal. That's okay. But I think this one actually does work out. -6 minus 24 is -30 over 5 as our x coordinate, and then our y coordinate, -8 plus 18 is +10 over 5. So I can divide as our final step. -30 divided by 5 is -6, and 10 divided by 5 is 2. So this point that partitions this segment into a ratio of 2 to 3 would be -6, 2. Please let me know what questions you have, and please, please, please give yourself some grace. I make mistakes when I do these problems, so you will as well, and learn from them. Write down the work you're doing so that way you can look back and try to figure out what went wrong in your problems.